Hi parents, thanks for joining me again. In my first video, I talked a little bit about the importance of building that foundation with our youngest students, our pre-K, K, first grade, and even up into second grade. How to build that foundation of number sense and why that's so important for their later ability to do calculations of all kinds as they go through elementary school. So we started talking about the idea of taking a number like 10 and breaking that number up. So we could break up the number 10 into 9 and 1. We could break it up into 8 and 2. We could break it up into 7 and 3. And we talked about some ways we can work on that. That is so crucial for kids to have that understanding, because as they get up into around second grade or even late first grade, they're going to start working on addition and subtraction with numbers, where they have to understand how to break apart those tens. So they might work on a number like this.
Students will start to see problems like this. 54 subtract 17. So I've built 54 with some straws. I just packed groups of 10. So I packed 10, 20, 30, 40, 50, and then I left 4 loose, because we're helping kids to understand that we're packing groups into 10s, and when we don't have a 10, we're going to leave those as 1s or loose. So I have 5 10s and 4 loose. And so when I want to subtract 17 using the traditional algorithm or the traditional way that most of us learned, I have to start to thinking about, how do I unpack that 54? I can remember my second grade teacher saying, well, if we're going to start with our ones, we are going to start by subtracting 4 minus 7. But if I only have 4, I can't remove 7. So I have to think about unpacking one of those groups of 10. So here's an example of that. I went ahead and took the rubber band off of one of my groups of 10 and separated those. So now, instead of one group of 10 and 4, I have 14 ones, but I still have my 10, 20, 30, 40, or my 4 10s over here. So now I have 4 10s and I have 14 ones. So when kids are starting to understand subtraction with regrouping, they're going to have to understand that 54 now becomes 40 and 14. So now I can see with my bundles of straws that I have still my 4 groups of 10, my 40, and my 14, because I unpacked one of my 10s. So now I have 14. Now I can subtract my 7. 1, 2, 3, 4, and 5, 6, 7. So I'm going to remove those 7. And you can see that I have 7 left. But I also have to remove the 10 from the 17. 10 and 7 made the 17. So I'm going to remove one of my packs of 10. And now what I have left are 3 packs of 10. So I'm going to show that on my paper here as 30, or 3 packs of 10. And so my difference is 10, 20, 30, and 7, or 37. Many of us learned it through a procedure, but the procedure was based on the mathematics, understanding what was happening with those numbers, with decomposing those numbers. So in the traditional algorithm that many of us used, we crossed off the 5 10s, and that became 4 10s, or 40. And then we basically moved one of those 10s over, which is indicated here by the 1, 10, and 4 ones. There's our 14. 14 subtract 7 is 7. And then 4 10s subtract 1 10 is 3 10s, or 40 subtract 10 is 30. And then we found our difference in an algorithm.
One of the reasons students have such a hard time with that idea of regrouping, or as we used to call it, borrowing back in my day, is because we didn't necessarily understand what was actually happening to those numbers. When we take the time to build that foundation and help them to see it with concrete objects like I did with the straws, and help them understand what's really going on, we're not really just borrowing or regrouping a 10, we're actually taking a 10 away from the tens place and moving it over to the ones place. That's a lot of complex thinking for a first or second grade student. And they really often have a hard time with that. We have the same issue when we add numbers and there's some regrouping involved. So we want to really take some time to help them understand what those groups are all about. I'm going to show you a few ways that you can work on that with just simple items at home.
As you can see, I just took some simple things that you might have around the house. One of the things we want students to do, or your children to do, is to start thinking about all the ways we can count lots of items when we have lots of items, and help them see the efficiency in counting in groups so that they start to see that connection between numbers. So let me give you an example. So I have here some packs of straws, and so I just took a whole bunch of straws, and every time I got 10, I bundled them or packed them up with a rubber band, and I ended up with 1, 2, 3, 4, 5 packs of 10 and then 4 loose, and that made 54 altogether. Here I did some pennies. I just took some pennies out of my jar and I stacked my group of 10 that I had, and then I had 1, 2, 3, 4, 5, 6, 7 left over, so that made 10 and 7, which is 17. I did the same kind of thing with some spoons. So I made a stack of 10 spoons, and then I had 1, 2, 3, 4, 5 left over, and that made 10 and 5, 15 altogether. You could use things like popcorn kernels. So I took some little plastic cups like you might have for condiments, and every time I counted out 10, I put them in a cup. So here's a cup of 10 and a cup of 10. I have 1, 2, 3, 4 cups of 10 and 1, 2, 3 loose, which makes 43. You could do the same with raisins. You could do the same with books. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could put a marker there and show that that's a group of 10. And then I have 2 more, and that makes 10 and 2, which is 12.
I hope you can see that what we're really getting at here is helping kids to develop that understanding of 10ness. And that's really critical for understanding all that we need to know about our number system. We live in a base 10 world. Everything in our number system is based on 10s. So look at this example.
One of my favorite things to use is an old egg carton. In school, we often use things called 10 frames to help kids see the efficiency in counting in 5s and then 10s. So I just took an old egg carton to make a homemade 10 frame. So I just cut off 2 of the holding places for the eggs, and I made a nice little 10 frame. So now I have 1, 2, 3, 4, 5 on this side, and 1, 2, 3, 4, 5 on this side. We want kids to start to see 5 and 5 as just knowing that's a 10. That's a double, and doubles are one of the first things that kids get when they're starting to learn to count in groups of or skip count. So I could take things like pennies or dried beans or popcorn kernels or cotton balls or anything and start to see how efficient it is when I start to count them in groups. So I have a group of pennies here, and I just drop 1 in each container. 1, 2, 3, 4, 5, 6, 7. I'm going to stop there, even though I have more in my hand, to show you a little bit of why we want to use things like 10 frames to help kids count. Once kids have done this over and over and over, they start to see that this side always equals 5, and then they can start thinking about a strategy we want them to be using in those early grades, a strategy of counting on. So if I already know this is 5, I don't need to count it. I can say, oh, and I know this side is 5, and then I just have 2 more. So they might do things like 5, 6, 7. Or as they get better at it, they might just say 5 and 2 make 7. I'm going to go ahead and finish off my 10 frame. 7, 8, 9, 10. And I actually have some more. So if I had another 10 frame, I could fill up another side, I think, here. 1, 2, 3, 4, 5. So I would have 5 and 5 and 5. I can skip count that as 5, 10, 15, or I can count it as a group of 10 and 5 more. And then I actually have 2 left over. So I can see that as 5 and 2 makes 7, or I can see it as 7 just by knowing that 7 after having counted many times and putting them in groups of 5s. So I have 3 groups of 5 and 2 more, or I have 10 and 7, which is 17. As your child starts to count things around the house, I encourage you to have them write down what they're finding out. Here's one way that I always like to do it with the kids. I have them make a simple chart like this one. So on the left column, we're writing down what items we're counting. And then on the next column, we're writing down how many packs of 10 we had. And then the next column, we're showing how many loose ones or leftovers we had. And then in the final column, we're writing the total. So here's an example. In the spoons, we had 1 pack of 10 or 1 stack of 10, and we had 5 loose ones, and that made 15 altogether. When I counted out my raisins, I had 2 packs of 10 or 2 cups full of 10, and then I had 3 loose ones, and that made 23 total. In my straws, I had 5 packs of 10, I had 4 loose ones, and that made 54, and so forth. So I want you to see what's happening here, and your students and your will start to see this pattern as well. 1 pack of 10 and 5 ones makes 15. There's the 1 pack of 10 and the 5 built into the total. 2 packs of 10 and 3 loose makes 23. Here's our 2 packs of 10 and our 3 ones, and so forth. Students really need to build that understanding of what these numbers mean. They can often memorize that 15 has 1 10 and 5 ones, but not necessarily understand what that 1 really represents. Here's one way you can really find out how much your child understands about place values. So for example, you might ask them to write the number 15 if they're able to do that. Hopefully after doing all these experiments with packing, they would be getting closer to understanding what these numbers mean. But if you really want to find out, have them write a number such as 15 and then draw 15 circles or 15 squares or 15 tally marks, whatever you want them to draw, as I've done here. And then you ask them, can you circle or shade in the number of balls that number represents? Well, a lot of kids will start to do something like this: 1, 2, 3, 4, 5. And then you say to them, can you circle or shade in the number of balls represented by that numeral? Early on, a lot of students will do things like this: color in 1. And then you say, what about all these others? You said that was all of the 15, but you didn't shade all of the 15. If a student really understands that this stands for 10 and 5, they will know that they would actually color in or shade or circle all 10 of those. So there's our 10 and there's our 5 represented here as 10 and 5 or 15. As I said before, this understanding is critical when they start to work with higher numbers, because our base 10 system is built on 10s. When we have 10 ones, we list that as 110 and no ones. When we have 10 tens, we name that as 100, no tens, no ones, or 0 ones. When we have 3,000, we list that as 3 groups of 1,000 and 0 hundreds and 0 tens and 0 ones. And that's what all of these stand for. So in order for a student to understand a number such as 4,159, they have to understand that all of these bigger numbers can be decomposed or unpacked into groups of 10. This 4,000 can be unpacked into 40 groups of 100. And this 100 can be unpacked into 10 groups of 10. And this 5 tens can be unpacked into 50 separate ones.
One final note about working on building this idea of sense of 10 and helping kids to make sense of skip counting and grouping is to just do everyday problems around the house as well. And that goes for kids who are still working on numbers up through 5 or up through 10. Just doing simple math problems around the house as they're helping set the table or getting ready for a group of friends to come over. We have 9 friends that are going to be here today. How many places shall we set? We have 9 groups of friends who are coming today, and I have 5 spoons. How many more spoons will I need? Or open-ended problems like this one. The answer is 10. What is the question? Kids might say, oh, how many fingers do I have? 10. How many toes do I have? 10. How many pennies are in my stack? 10. They can come up with really creative ways to answer that question. So word problems can just be everyday things that you're doing around the house. Thanks for visiting today, and I hope to see you next time.